to share. And then I need to go over what we need to do. Okay, so you have some notes here. All right. So we're going to be talking about those. So when we are talking about naming and names and formulas for ionic compounds, we've been talking about these polyatomic ions. These ions are made of more than one atom. You saw that yesterday in your POGL. The charge is given to you. It applies to that entire group of atoms. The ion acts as an individual ion. So when we start going through and we're starting to do reactions later on, right after we get back from semester break, you're going to see that that polyatomic ion is going to carry through that reaction and stay together as a polyatomic ion even after it goes through that reaction. So if you start out with lithium nitrate on one side, it's going to rearrange, but it's going to be something else nitrate on the other side. It's just going to go with a different metal. Okay. You are never going to change the subscripts of the atoms within that ion. And if more than one of those polyatomic ions are needed, we put parentheses around it. We have these things called Oxy Anions. An Oxy Anion then is a polyatomic ion, and this is going to make sense, is a polyatomic ion that has oxygen in it, and it's going to have what kind of charge, positive or negative? Negative, because it's an anion. Now, these rules that I'm about ready to go through with you here, about this 8 and ite and all of that, these are found on the back side of your periodic table in this chart. Okay, right up here. So you will have this on every test, every quiz. So you can use this like a cheat sheet to help you along and figure out how this works. All right, does that make sense? Now, the most common form of these Oxy Anions that exist out in the world end in the 8 version. And those are the ones that are listed. If you go through here, most of these end in 8. Do you see that? That's the most common form that exists out in the world. And you've probably heard of like sulfate and nitrate and different things like that, right? And just in common vernacular. If we take an oxygen away, we change that ending from 8 to ite. It's kind of like in like foreign language, you conjugate your verbs. That's kind of what we're doing here. Okay? We're doing kind of a conjugation here. And instead of changing how many people are involved, like with your conjugation there, we're changing how much oxygen. Does that make sense? Is that a decent analogy? Okay. I think all of you have had some foreign language, some degree of it where you have to conjugate, right? I don't know how it works in Chinese. I know in French and Spanish it works that way. But your Oxy Anions, then, if we end up adding an extra oxygen to that, we add per in the beginning. And if we take 2 oxygens away, we change the beginning to hypo and ite. Okay? So let me escape out of here and go over to here and pull up a document that I can actually write on. Make this big enough so you can see it. All right, so let's take if you flip over in your packet, you're going to find a sheet that says Polyatomic Notes. It's right past your POGL. Do you see it? It looks like a bunch of charts. What's the example one on the top there? Yeah, is it chlorine?
Yeah.
Okay. And what's the next one down? Where you have sulfur? Sulfate? Okay. All right, so let's do the sulfate then. You can see the chlorine. We gave you that as an example. You can follow along with that. This is the sulfur. Okay, so this is the sulfate. So on your periodic table sheet, about 2/3 of the way down in the first column, you're going to find sulfate there. Okay, this will always be for you. You don't have to memorize this. So if we have sulfate, 8 ending is our most common form. And they told us that sulfate is SO4 with a -2 charge. None of this do you have to memorize. Okay? None of the rest of this do you have to memorize. You just need to know how to conjugate it. All right? Now, if you saw this with 1 fewer oxygen, it's still going to have a -2 charge. The charge doesn't change. But how we indicate to people that this is no longer this, but has SO3 -2, is that we're going to change the ending here to say "ite." So this name then becomes sulfite. Okay. So it's just like in Spanish where you go hablo, hablas, hablaba, hablamos. It's been too long. So I had really, really bad Spanish teachers too. But I remember that much. I mean, it was like habla, hablo was like the singular form, I think. And then habla. Yeah. There was hablamos and hablas, something like that. Yeah. So anyway, it's the same idea. You're just conjugating this differently to show different amounts of oxygen instead of different amounts of people. Okay. So we can take another oxygen away. So we're going to take this guy and we're going to take 2 oxygens away from this original form. And that's going to become a -2. Now we have to do 2 things to it to show that we took 2 oxygens away. So this is going to be hypo, is going to be the beginning. So that's hypo. And then we're still going to end it in ite. So this would be hypo sulfite. Does that make sense? We can also add an extra oxygen to this original form, which would make this SO5 -2. And what we do is we add a per in the beginning, and then it's still going to be an 8 ending. So this is going to be per sulfate. So you're just conjugating it to show that you're changing that amount of oxygen. And you're telling the people that you've done that with your words over here. So you show them with your formulas and you tell them with your words. That makes sense? You handle that? All right, so let's try another one. What's my next one on there? Going down. Phosphate, okay. So phosphate on our sheet, they're going to give us that on here. So that's found on this sheet. Again, you're not going to have that memorized. Our phosphate Yep, that's about halfway, a little over halfway down on that first column. Okay, you're going to see phosphate there. Phosphate then is, oh, I should keep these in the right column. This is phosphate. It is PO4. It has a -3 charge. So if I add an extra oxygen in, that's going to be PO5 with a -3 charge. I'm going to have to change the beginning to show that I added an oxygen in. So this is going to become per phosphate. Everybody okay with that? If I take an oxygen away, how do I indicate that in my name? Ite, yep. And then I'm going to take an oxygen away. What am I going to do with the charge? Right, I'm going to do absolutely nothing with the charge. That's my phosphite then. I can take another oxygen away. And how do I show that? Hypo phos what? Ite. Good. All right, what's the next one?
Carbonate.
Okay, yeah, I like that one. All right, we'll do that one, and then you're going to do the rest of them on your own. All right, so it gave you percarbonate in the chart. Okay, so percarbonate. And percarbonate then would be CO4 with a -2 charge. You can get carbonate from here because that's given to you on your chart. It's right here. See that? You find carbonate on here. You're going to use it a lot this year, so get used to where it's at. You probably even end up accidentally memorizing it along the way. Not that you have to, because you'll always have your sheet. I don't know where that R came from. Okay, so there's my carbonate. I can take this and I can take another oxygen away. And that becomes what? Carbonate. And I can take one more away. And I'm not going to write the 1 down here. I'm just going to write the -2 charge. And that's going to become what? Hypo. So I change the beginning. Carbon. And then ite. Okay. So we're just concentrating on the prefixes and the suffixes for these. I guess the prefix didn't change there. Get rid of that. Suffix. And then here we've changed 2 things. We're going to change that. Good. Does that make sense? Do you see how to conjugate those? I'm going to use conjugation because I think that's the best analogy to this. Hi, here's Matthew. He's going to give you his version of why it is important to learn your formulas.
This stuff?
Everything. All formulas, writing, acids, everything. Just give them your take as an AP student because it's better if it comes from you than me.
Yeah, it's in everything. It never goes away either. So when she like says that like this stuff is really important, even if it's like hard to learn at first, just like do all the practice because in the end you will get good at it. Like everyone that's in my AP class, I know there are people that are like, I hated this in the beginning, and then they just did all the practice, and at some point it just clicks. Like it may take longer for others, but if you do the practice, you will get better. And like it never goes away, so you might as well just suck it up and do it, then just forget about it because it's just gonna make everything a whole lot worse. That's pretty much it.
Yeah. Okay. Just giving you a perspective of somebody else.
She was hard on me too. Don't worry. She was hard on everyone. But it's important that she is. Otherwise, you guys just.
You're gonna suffer second semester. Trust both of us.
And it only gets harder.
Yeah, because if you can't do this, you're not gonna be able to do this stuff in the future. So okay. So that's why I bring people in like Matthew to, impress upon you the importance of it.
AP Chem is a lot of fun though. Like even if it's like, if this seems hard, it's like, it's worth taking it. It's a fun class and like you learn a lot. And it's better, even if you don't like want to take the AP test or you do and you don't do so well, going into college and then taking this class again, it'll be so much easier. You'll have so much of an advantage to people that didn't because you already have like a head on all this stuff. So.
So
and it's all
if you're interested in AP, but
labs are fun too.
Yeah.
I like labs.
Thank you, sir.
Yep. No worries.
All right. Yeah, always. Okay, so getting back to these, does this make sense to you? Are you comfortable doing this?
Yeah.
All right. So I want to take you from here into what you're going to work on tonight then. Okay. If I can find it. Where did I hide it? It is here. Here we go. Okay. So you're going to get a copy of this. And this is going to take you through a slide presentation. And I'm not going to have you turn in the actual slides. You're going to be doing your work on your homework there. And we'll do the first maybe one or two together here in class. So if you flip over to your homework for tonight, so you're going to finish those notes that I just gave you, which will take you all of maybe 2 minutes. And then this is actually going to be what your actual homework is for tomorrow. Okay. You're going to start with these naming and writing formulas. So on here, you're going to be given some pictures. So this is a calcium, and then you're going to have these 2 chlorines. So you're going to have these pieces. You'll actually just have something like this on the screen. Okay. And you've got to figure out how you can put these together to cover all of the arrows and not have any of these prongs left behind. So for example, if you were given this calcium, you bring up this chlorine, and then you'd make another chlorine. You just copy and paste and make another chlorine to have it come in and meet up here. All right. And what that's going to do is then you're going to get your formula from that. So your formula is going to be CaCl2 because you had 1 of these and you needed 2 of these to make that work. So that's your chemical formula for this is CaCl2. The name then, the name of the compound, you're going to list the metal first, and you should know which one's your metal off the periodic table. We also have them color coded, so they're like in the blue family, and then these are in the red family, so that helps you too. So your metal's always listed first, and you're going to use Roman numerals if we have an asterisk, and I'm going to show you an example of that in just a second. Here we didn't have an asterisk with this one. It was just calcium. And this is calcium. And then we have chloride. We changed the ending from chlorine that appears on the periodic table to "ide" because now it's part of a compound. It's not by itself anymore on the periodic table. It's become part of a compound. So we have to change the naming to show people that it's in a compound now. All right. So let's look at another one here. Here's bismuth. So for bismuth, I would have given you one of these nitrates over here somewhere, and I would have given you this bismuth. So if you bring up the nitrate here, you can see that there's still openings on this bismuth, right? So I would have to copy and paste this and create a new one. And I've got another nitrate here. And that still didn't fill this up. So now I need to bring another one in. So my formula ends up being Bi. I only needed one of those, so I don't put a number down here. And then I have my nitrate here. This is my formula for nitrate, but I needed 3 of those. So I have to show that in the parentheses here. So I show that I have 3 nitrates. I can't just put a 3 down here and expect that to work, because that would be 33 oxygens, and that's just kind of silly, isn't it? Okay. So I have to give it a hug and show you that I've got these 3 nitrates. Now, do you see how on here I have a star? That means that you're going to need to have the name in parentheses here, or the Roman numerals. Now, how do you get 3 Roman numerals? You count the number of arrows on the bismuth. So I had 3 arrows here. I'm going to put 3 in Roman numerals. Now, why do some of these have asterisks and some of them don't? Well, look on your periodic table. Find the calcium that we used first. Do you see how calcium only has one of those numbers there, one of those charges? Okay. We don't need to tell people which one to use because there's only one option. Now, if you travel over to bismuth here, do you see how bismuth has 2 different options? We have to tell our reader which one of those we're going to use. Okay. And for today, the way you're going to know which one to use is you're going to count how many prongs are coming out of here. Yeah.
On the formula, how did you get the 3 that's outside the parentheses?
This one?
Yeah.
I needed 3 of these to balance this out.
And so why is there 2 3?
Because nitrate is NO3. So if we kind of enlarge this, I have the formulas written on here for nitrate. It's also on the back of this sheet too, if you need to see what nitrate looks like. Fair question. Good job. All right, other questions, other things that aren't making sense to you. All right, let's do another one together then. Do you have to write this one down on your sheet?
Yeah.
Did you get it written down? Okay.
What was it for the calcium chloride?
Here? Okay. All right, so let's see if we can figure out the next one here. This is our lead carbonate. So we've got a lead and we've got a carbonate. And when we bring these together, we can see that we're covering both of the arrows. So we're only going to need one of these carbonates. So then we can write our formula out. So our formula ends up being, let's see if this will let me type in here or not. Oh, PbCO3. Now you're going to be doing this on your paper, which is going to make this a lot easier for you because you can do the subscripts. Easy enough. I don't know that it's going to let me do this. How do I do this on here? Oh, I think, no, I don't know how to do it on, is it on plus? text. Here we go. Subscript, control plus. Okay. So there's my formula. My words then, I'm going to write lead. I'm going to need a thing. I'm going to need Roman numerals here. Okay. And it's lead. It's going to have 2 prongs coming out. So that's going to be a 2 for my Roman numerals. And then I'm just going to write in carbonate. I don't need to change the ending to "ide" because it's not just a single element. It's a polyatomic ion. Does that make sense? Okay. So that's what my lead carbonate ends up looking like. And then you've got several of these to work on your own as well. Okay. So I will get this slide presentation posted for you as soon as this video recording is done. And then you'll be able